Yeah, hello everyone. I welcome you all to this MLP live session. Yeah, first, as we decided, we will start with the code demonstration, and yeah, after that, we'll. Whether my screen is visible or not, can anyone confirm? Okay. Yeah, so let me see. Okay, so still, who has made that slide? Made that collab hasn't shared it with me. Okay, so and yeah, I think some noise would be coming because I can't stop that. Yeah, so I'll slowly go through this code collab, and after that we'll start discussing the questions. In this collab, Canon register part is the covered. So if as the we have already worked on this dataset earlier also, but here they are using their Canon register method. And I think most of the codes are already you are able to see in the search lecture only, because I also saw that no code is hidden this time, particularly in this lecture series. So performing randomized CV. So whether my pace is correct, or I should increase or decrease my pace to show the slides. This collab. Hello. Hello. Whether am I audible or not? Hello. Hello. Am I audible or not? Hello. 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 Yeah. Please respond. Otherwise, I am feeling like I am only speaking, and whether I am connected or I got disconnected, I'm not able to get that idea. Okay. Yeah. So if you want, I think I should, yeah. So now the polynomial features are codes are discussed, like they have applied this polynomial features with degree equal to 2, and yeah, they have applied the min-max scalar and the Canon regressor. And yeah, that's all in this collab. Okay, we'll quickly discuss the activity questions. Hello.
Yes, yes.
Yeah, please speak. Otherwise, I'm
Okay,
feeling
okay.
like either I got disconnected or what.
Yeah.
Today, some marriage ceremony is near to my house, so, so at some time you
What
will.
happened?
Some marriage ceremony is happening near to my house, so sometime you will get the sound of this some songs and all.
Okay, okay, okay.
So please ignore that. Yeah. Let me just. Yeah, we will start discussing the questions actually. Uh, So have you gone through the activity questions and programming questions and all?
No,
Hello?
not completely, not completely.
Yeah, because this time it released late, bit late, no?
Yes, that is one, and secondly, like I was doing the MLT stuff. Yeah, okay.
Yeah, yeah, that would have taken time, more time, no?
Yes, actually, like there was one thing like this categorical cross entropy, right?
Yeah, yeah, yeah.
Yeah, so can we discuss something on that? Because categorical cross entropy, like why we need to like kind of minimize that value actually? Because to me, it looks like maximizing that value should be good.
See, first thing is that like I haven't gone through that MLT part, but yeah,
Oh,
I
okay, okay.
know about that about that, but yeah, I don't know that what sir has covered in that MLT part. Okay, it would be better to ask that question in MLT session, but I will
Mm-hmm.
tell you about the uh, just in general view, like entropy. Do you know about this term entropy?
Yes, yes.
Yeah, have you heard where you have heard this term entropy?
Entropy is like whenever there is a probability distribution involved, like that time that the entropy comes into the picture, and it says like what is the information content in the output.
Entropy. I won't say
Yes.
exactly that. Entropy means not exactly that. Entropy means just assume a library. Okay. Hello.
Mm-hmm.
Just assume a
Yeah.
library, like where every book is kept at its place. Okay. So at
Mm.
that time, just think as entropy is zero. Okay. So, or just one word to replace this entropy term is randomness. That's the best word I thinking, according to me, to replace this word entropy. It's just like in randomness. So at that time, the library is like completely all the books are kept at its own place where it is supposed to be kept. Like for computer science, book is kept at the computer science that that cell, and yeah, like that only. Okay, so what
Mm.
you do, like some child comes and yes, he just put some book, he just draws some book from one place and just place at some other place, so all the things will be randomized. Okay,
Mm.
so yeah, so that at that case entropy will increase. So it is a general term. Okay, like that's how entropy works, and you would have learned about this term in thermodynamics in 12th class.
Ah, yeah. Mm.
Yeah, yeah, there you would be knowing like how, like after the degradation of energy, that entropy increases,
Mm.
and you would be knowing that yeah, entropy of the world is continuously increasing. So
Mm.
yeah, that is just a randomness. So obviously entropy word, you can understand from the entropy word, yeah, it is a term which we are supposed to decrease. It is kind of like that. Okay, you can just discuss that part, that because I will, otherwise it will take a session to or since it is discussed in that course, no?
Yes, it is discussed in that course, but since we are using that multi-class classification here also,
Yeah,
here also essentially we are kind of measuring the distance between the output levels and the true level, right? And both, you have two ways. You can take a like a squared error. Okay, because you can treat that output as a vector. Output is a vector, and your true level is also a vector. So you can find out what is the distance between those two vectors. This is one way of thinking that. Another is, since it is a probability distribution, you can do something better than simply like getting the distance between them. Okay, and that is expected value. Like when you do this cross entropy, there are two way of looking that. Okay,
Yeah.
one is like you can say that it is the expected value of the output, the expected value of the information content. If I look from that perspective, then maximizing the cross entropy will make sense. Another perspective is like you are looking from the distance perspective, like cross entropy as a distance. Okay, that time like you will see that okay, minimizing that makes sense. But why a single thing has two different perspective and both are like 180-degree apart?
Uh, I would say I need to also check that because I haven't gone through that MLT week 7 lectures.
Yeah, like
Yeah.
I asked these questions like I think quite some time back, maybe like while it is in week 4 or week 5, that time frame.
Which
Then
one?
I
See,
posted this also in the discourse forum.
I need to see that, but I would say in general, what happens, whatever I have knowledge, that whatever you are thinking about this entropy term is, I think you are thinking in opposite way. Okay, but I need to check that, whatever I will say. But what
Okay,
I, yeah,
so I
because
have posted something in the discourse forum. If you happen to check that, like try to
uh,
respond that and put some
okay,
more
okay,
thoughts over there.
okay, yeah, just tag me because see, this time I'm just going through this MLP part only. So
Okay, okay.
yeah, that's okay. Yeah, so yeah, the first sentence is a softmax regression algorithm is used for solving multi-class classification. Yeah, that's true. And the softmax function normalizes the input vector into a probability distribution. Yeah, that is also correct
Also
statement.
true. Yes.
Yeah, so both statement 1 and 2 are correct. Okay, to solve a multi-class classification problem using logistic regression estimator, we set multi-class parameter to. Can anyone answer?
Multinomial.
Multinomial. Okay, yeah, correct. So what does mean this OVR?
Uh, uh, one versus rest.
Yeah, one versus rest. So what is the difference? Can we solve using OVR multi-class problem?
Yes, we
Uh,
can, because like in that circumstances, like you have you'll have multiple estimators.
exactly. Yeah. So that is the main difference between OVR and multinomial. So yeah, you can say what is the difference between OVR and multinomial? So why multinomial came into the picture?
Because like in OVR it is kind of you no need to like kind of create a OVR is kind of a binary stuff, binary
Yeah.
binary classification, and multinomial is like there you are taking that probabilistic approach, like output you need to normalize it to a probability, like softmax.
Yeah, so the main, the biggest difference is yeah, that whatever you said that is correct, and yeah, the biggest difference is in multinomial we just change this the loss function to your cross and
Yes,
yeah,
yes.
yeah, correct. So which one is a different algorithm? Logistic regression, softmax regression, k-nearest neighbors classifier, polynomial regression.
Different. It's Q nearest neighbor.
Mm, see, I would say in this question we can see it in two ways. First way, I think yeah, the correct answer is given as I think yeah KNN only. Yeah, correct answer is given as yeah KNN only. But I would say see here, all the other algorithms are classification algorithm. These three, but this polynomial regression algorithm is only working for the regression problem.
Oh, okay.
Yeah. So yeah, I think, but the answer is KNN only, KNN classifier, because we can select this one based on that. Yeah, the working.
Euclidean or Manhattan
Yeah,
distance.
yeah. And the principal concept behind these things are same. So yeah, based on that we can select. But yeah, I think yeah, the
Yeah,
answer
it's
should be both.
actually ambiguous question.
Yes.
Hmm.
So given the following confusion matrix, calculate the accuracy score. So accuracy score is we know that yeah, actual true and actual false. Yeah, true predicted 939 plus 842 upon all sum of all the
Summation
things.
of all these things, yes.
So it will come around 0.98. Yeah. So which of the following scalar modules implement the confusion matrix method?
Matrix, scalar matrix.
Yeah, scalar dot matrix. Yeah. So which of the following scalar objects are useful for discovering the best value of k for a Cannon model? Which one you think? Yeah, we can use the grid search.
Yeah, grid search, even
And
randomized search.
validation curve is also. Do you know another term for this validation curve? Like elbow method, we say this. Why we call this elbow method? Because the shape comes somewhere.
Well, what is the question? Like I couldn't get that.
This to get the k value, that validation curve is there. What is the shape of this validation curve? It is somewhere like this elbow shape actually.
Okay.
Yeah. So we also say it like a elbow method to get this k value, optimum k value actually.
Okay.
So these 6 are done. So let's go for the next 6 questions. Activity 7.2. So which of the following scalar module implement relevant function for the nearest neighbors algorithm? Okay. So I think you all knows that SQL.
The first.
Yeah. So second question says, for every data set, there exists a threshold k naught such that increasing the value of k beyond this threshold does not significantly affect the accuracy of the model. And the second one says the let and denote the number of training data points for every data set. There exists a threshold and not such that increasing the value of n beyond this threshold does not significantly affect the accuracy of the model. So second statement is true, because after a certain point, whatever the you increase the data set, it won't affect your accuracy that much. But first statement is wrong, because cannot definitely affect the accuracy. Okay, so I think statement 1 is false, statement 2 is correct. What does the value in k?
But say for example, if k is more if you're like a maximum value of k can be like your data set, right? Length of your data set.
Number of features actually. Correct. Whatever you said, correct. So as for that cannot to make a one you can say that to one samples, one classification model, like you took all the data set value in one circle. At that time the accuracy will be 1, no? Like every time that it will predict that class only.
Correct. So beyond that, even if you increase k, like it will not change the accuracy.
So that is the highest one, no? Like that is the
highest one. Yes.
1. So obviously it won't increase from 1. But if it is between 0 to 1, then it will go reach at 1.
Correct.
Yeah, but whatever the point you said, that can be that we should this question we should be framed in such a way that we should say that
it should be less than that.
What does the value k in k nearest neighbors algorithm refers to? So what is the way k? Can anyone say apart from you? Like some other people just speak. It would be good if we have more number of participants. Hello. So okay, Rajiv, just you say speak, because no other people is speaking.
That is the to calculate the neighbors, how many neighbors you should consider like the closest neighbor.
They will also type so correct. Number of nearest neighbor to consider for each data. Which of the following statements are true? One more thing. Can you say the other term of other name of this softmax regression?
Other name of softmax regression? No.
There are maximum entropy classifier also. Maximum classifier or maximum entropy classifier. Which of the following statements are true? Canaan model with low value K produces complex decision boundaries. True, no? Yeah,
Yes, yes.
yeah, that's true. Canaan model with high value of K produces complex decision boundary. No, no.
No, this will
Yeah,
be smoother actually.
yeah, yeah. K model with the high values of K produces simple decision boundary. Yeah, these two are correct. So
Yes.
yeah, a given test data point in Canaan can be thought of being as being situated at the centroid of K nearest a K training points nearest to it. That's a false statement. Yeah. Second is if x1, x2, x k are the K nearest data point of x, then y predicted x equals 1 by K sigma y x of I. So yeah, that the statement one is false and the statement two is correct. One more question came in my mind. Yeah. So you would have heard this term lazy learning. Hello.
Lazy learning.
Yeah. So whether Canon is lazy learner or eager learner. Okay, before that I should ask what is eager learning and what is lazy learning. Have you heard this term?
No, no, no. I heard like in programming stuff, like there is something called lazy loading. That I
Okay,
know.
no, no, no. Lazy learner and eager learner.
No, lazy learning.
Actually, we divide the algorithms into these two categories. Like
Okay.
some algorithms are eager learner and some algorithms are lazy learner.
Mm-hmm.
So, any idea? Just think about this term, like what you infer. I'm asking you because then you will be able to remember it for longer period, for longer time. So,
So could be lazy could be like something till the time you are not asking predict, it will not fit that data.
yeah, that's yeah, pretty close to the correct answer. Yeah, the thing is, all the algorithms which we have studied till now, those were the eager learners, and this one is Canon is lazy learner. What happens here?
Right, right. It doesn't have a model actually.
Yeah, that only. That is the thing. Like it's like whenever for other models, what happens is they are eager. When once you give you the data set, they learn from the data set and they predicted a model. They created a
Right, right,
model.
right.
So whenever you will give the new value, it won't
Hmm.
go to the older data set. It will
Right.
just predict on based on that model only. But
Hmm.
what happens in the Canon is like it is so lazy that it waits for the question to come. Like when you give it to the new data point, then again it will go to the its old data training set, and yeah, at that time it starts working. Something
Correct,
like
correct.
that.
Yes, yes.
That's why we say that Canon is a lazy learner.
Hmm. Hmm.
Okay, okay, yeah. Which of the following are false regarding Canon? Canon is an on-parametric supervised learning algorithm. Yeah, that's correct. The number k in Canon is a parameter to be estimated from the training data. No, that's not a correct. The time complexity of classifying a test data point using Canon depends only upon the number of training instances and not their dimension. Yeah, that's wrong because it depends on
Hmm.
both the things. Yeah. So, have you learned about this time complexity in Python? How we
Time complexity.
how we
Go
calculate
ahead.
time complexity?
Yeah, we have a idea like how to calculate the time complexity, whether it is a order n time or order n squared time.
Yeah, yeah, yeah. Just otherwise, if you don't know, like there would be many times when you will sit for some interviews, no, they will ask it's normal like objective questions. Yeah, what is the complexity of this time complexity of this model, something like that.
Hmm, hmm, hmm.
Yeah. So yeah, that's you can learn about that, or if you know that's a good thing. Yeah. So
So
can you?
so for all these models, whatever we are learning, we should know their kind of
No, 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 no. They won't ask for these things. But yeah, sometimes they give the simple equation, yeah, simple format, and they ask the time to calculate the time complexity.
okay, 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 that
Yeah,
kind of thing. Okay, yes,
yeah.
that
Oh,
we can calculate actually.
yeah, 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 yeah. Yeah, when something like that. Yeah, Canaan model suffers from the curse of dimensionality. Uh, curse of dimensionality. So, what do you understand by this curse of dimensionality? That's the correct answer here. Yeah, it suffers from that. So, have you idea about this term curse of dimensionality? So the thing is, the curse of dimensional terms you can understand like the when the dimension of your model increases, no, it suffers to predict the output accurately. So it happens with the Canon also. Like just think like if you have 100 dimension, okay, when you have increased dimension to like 200, 300 point, 200, 300, something like that. Yeah, very large dimension. If you have, then like all the some random noise will also have some impact. So in that case, Canon won't perform well when the dimension of your model will increase. So have you worked till now? Have you worked with this data set? No, amnesty data set. No. Hello. Hello. Please speak up. Otherwise, I will just go through these questions only. Like I won't try to speak some other things. Okay, let's go to the then next questions. Which of the following scalar objects are relevant to perform classification using k-nearest neighbors? So yeah, that is both nearest neighbors and k-nearest classifier. So both A and C are correct options. So which of the following is true regarding the weight parameter of the k-nearest classifier class? Okay, so it is concerned with the parameter weight of the Cannon model, and it represents the relative weights assigned to each class labels, which are to be considered during the majority vote. Yeah, it represents the relative weight assigned to all neighboring points as a function of their distance from the test point, which are to be considered during the majority vote. So which of following option you think that is correct? Okay. No one is speaking.
Yeah, I got disconnected actually in between.
Okay. So yeah, you left around. Yeah, when we are talking about this curse of dimensionality. So I was at that time I was asking the questions. Yeah, have you worked with this MNIST data set? No.
Yes, yes.
Yeah. So they have in that data set we have 784. Yeah, features something like that. No. So why it is so large and why? I mean, what is it?
Because there is a image data, right? Image data. So 28 by 28 image.
Pixel, yeah, 28 by 28 pixels. So yeah, that is what represented in 784. So what we do, like that's how we work with the image data set. So what we do is that we just take the area of that pixels and we just flatten it, and all the pixels becomes a feature, yeah, a feature for this data set. Like that only we work. Yeah, whatever you said, that is correct. Yeah.
Yes, in fact, I think like MNIST has another version which has 512 by 512.
Okay. Yeah, there would
Yeah,
be
because that is generally used in CNN network.
Yeah. It would be. It is there actually. It is there. Yeah. So in that, the pictures are more clear. Field plot. Yeah, that's correct. Yeah. So yeah, which of the following is true regarding the weight of parameters of the Canon K-universal classifier? Yeah, that's the correct answer actually given. Yeah. So have you learned about this? All the methods, these algorithms, brute force, and some other algorithms are there, or do you just use that automatic?
Which one? This brute force?
Yeah, brute force k-nearest algorithm. There are very many methods, many algorithms, no, to calculate this. Solver as a solver, I think. Yeah. Actually, we use the auto technique, but I would suggest if you want to learn more that in Scalar, the links are given to these algorithms. Paper, there are papers
Okay.
based on this, so you can refer that. Yeah, the chosen distance matrix and number of training points. These two affect this nearest neighbors algorithms. Yeah. Which of the following scalar objects help us find the k nearest neighbors of a test point within a given training set? Yeah, that is the correct, like k nearest neighbors classifier and nearest neighbors. No, k nearest neighbors class. Let me read the question properly. Which of the following scalar objects help us find the k nearest neighbors of a test point with a given training set? Yeah, that's then yeah, B and C are correct. So when so this question is just simple. Yeah, we can see think our like when k is lesser, then what will happen? Like it will,
Overfitting.
yeah, and when k is higher, the it will be underfit. Like
Underfitting. Yeah.
yeah, so yeah, like that only. Like we can think about the variance part only. So I think yeah,
Hmm.
more or less we have covered this part. Activity question 7.3.
So you are saying in that k nearest neighbor, even like you can use some solver other than auto, right?
Yeah, auto just it selects from itself. So we have no this
Right.
brute force and all.
Yes, we heard about that SAG, then leap CFG and all those things.
Let me just see. Yeah, can you just search? Okay. No,
Okay, okay, okay,
I'm just also forgetting this term, but you just search about this. Okay. So the
okay.
papers are there for this like brute force and other some other algorithms are there. So and
Hmm.
just I would suggest yeah this one, and also like how partial fit works, like this partial fit. No,
Hmm. 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 Hmm.
how it works for different
Okay.
cases, like to calculate the how in the MLP graded question, one question is there or no, like today also one guy was asking on the discourse. I haven't replied that but yet, but that question was like you have to work about you have to know about, yeah, you can just I will do a sample question on this, like how we will implement and this one partial fit for the yeah standard
Yeah,
scalar.
that partial fit is like you don't apply that final thresholding. Like you return the direct probabilities, raw probabilities. That is your partial fit.
Yeah, but for this part, like how partial fit works for a scalar, sorry, standard scalar. Like, see, what
Okay,
is a
okay,
standard
okay.
scalar does is it calculates the mean and standard deviation for
Hmm.
all the values. No,
Hmm. Hmm.
like
Hmm.
what? But you in first sample you have just first part of this, like one chunk of your data set. No,
Hmm. Hmm.
yeah, for that only you if you will calculate this mean and standard deviation, so that will be calculated for this chunk only. No,
Okay,
so you are, yeah, for that also one algorithm is there. So one paper is there, you can see that, you can refer that paper, like which
okay,
formula
okay.
it uses for your knowledge, just for your knowledge. Yeah,
Hmm.
otherwise you can just use, or you just think like how you will implement this standard scalar on the data
Standard
set.
scale. Okay. Uh-huh.
Yeah, it would have and when to train and when how to yeah transform the data set.
Hmm. Hmm.
Yeah. So this part is done. 7.3. See, the thing is that these lectures are like very dense. I mean, so many things are as covered in this week, this 12 week. So you have to work if you want some to gain some extra edge and gain some extra knowledge, you have to work like there are many small things which is left, and you have to just to learn those. You have to do some extra effort.
Hmm. Hmm.
Yeah, so that's why,
Yes.
yeah, just I'm just pointing those things, whatever
Hmm.
came in my mind. Which of the following can be used to evaluate performance of KNN model? So yeah, we know that to evaluate the performance of KNN model, we have to see like it depends on the like I think the questions is a bit incomplete because I think we should mention that whether it's a KNN regression here or classification model.
Correct, correct, correct. Yeah.
Yeah. So yeah, this question. So based on the following statements, select the correct options. It is essential to perform feature normalization before performing KNN classification or regression. The distance matrix used in KNN may be sensitive to the relative scales of the features, which may prove problematic for dataset having substantial discrepancies among scales for individual features. So I think you might be knowing the answer. So, but see, why we need the feature normalization? Can someone answer? Or is this,
Feature normalization, right?
yeah, why not we normalize the data?
Yeah, because the different features are in different scale. That's what all bringing all these two in the same scale. We normalize that feature.
So yeah, that is
Otherwise, it will be skewed actually.
uh, it will be skewed, but that's not yeah. So if we have one feature from So what will happen? Like if we train our model, Canon model, like without normalizing the data.
Yeah, so like in that circumstances, like say for example the distance the data like which is far away, right, like the distance will be much higher, and those will never get selected.
Yeah, yes, like that only. Yeah, we have just two data, like one is your height and one is your width. So height would be given the feet. Okay, so it would be around, yeah, like, yeah, 1 to 7. Yeah, the height will vary from 1 to 7 feet only,
Correct.
and yeah, weight is somewhere around, yeah, 20 to 100. So both the things are not like it's not matching. It will just, if you will assign equal weight, that won't work. So yeah, for that, in such cases only, like, so that's why the feature normalization is needed, so that we scale down to scale down everything, scale down and scale up, and bring the all the data, all the features on the same scale.
Same skill, yes.
I think that's why we, yeah, yeah. So based on the following statement, select the correct option. As k increases, bias of the Cannon regression model increases and variance decreases. Okay. Yeah, that's the correct case. As k increases, bias of the Cannon regression model increases and variance decreases. Yeah,
Variance,
decreases. Because so the like how the bias is calculated. Bias,
What?
like yeah. What do you understand by data bias?
Bias is basically expected value of the error.
Yes. Expected. Yeah, that is exact definition. Yeah, that whatever you tell, that is.
Hmm.
So bias. If we talk about the bias of the model, so what you understand from this term, like bias of the model?
That means the data is not properly fit, but still we are saying, say for example it is a linear model, okay, and data is kind of a circular, but still we are saying that this is a linear model, so that is the bias of the system, because it will produce more error, so it is kind
Yeah.
of leads to underfitting.
Yes. Right. So yeah, that is whatever you told. That is correct. And also one thing is, I would like to add, like, to if you when we talk about the bias of the model, it is like we took multiple data set, we created multiple model, and it is talking about that average error. Okay.
Right.
Yeah. Yeah, that's true. Because I just asked because when I was learning that, at that time I was thinking that bias. I was thinking about that. Yeah, it is calculated in that, how it is calculated in that particular model. So, but yeah,
Hmm.
it is like a bias of the model. When we talk about the bias of the model, it's the average error from the, like, yeah. We trained many different models like that.
Hmm.
Yeah. So Canon models are highly sensitive to noise and outliers. Canon model are highly
Yes.
sensitive to noise and outliers for low values of, yeah. That's correct. So one method is there. Just I as I talked about this, no. Uh, this one, Canon is like it suffers from curse of dimensionality. To remove that, there is one method. Just learn about that. Just, I would say, just you can just check that. Otherwise, just know the names at least and just check. Search that. Okay, yes, I think we are done with this one.
So is it other than PCA?
Yeah,
Okay,
for
okay.
this one, yeah, for this one, like in Canon particularly, I'm talking.
Okay,
Canon,
okay, okay.
yeah. So it has some modified version like that. You can think.
Acha.
Yeah. What?
Srinivasan here. I did have one question about bias. Maybe it's a larger question.
Yeah.
Why are we looking at bias only when it comes to softmax? Because this thing exists for every other regression or
Yeah.
classification
Yes.
problem that we have seen.
Yet, yes, it exists. Always there is a one term, I think sir has not covered, bias variance trade-off. Is it covered in some
Yes,
lecture?
yes. Covered.
Yeah. So yeah, whatever you are saying, Srinivasan sir, yeah, that's true. Like bias comes into the picture in every problem, like every regression and classification. So it is, yeah, you have to just balance between bias and variance. So that's why this bias variance trade-off is
Yeah, but
happen.
why are we in softmax? We are including that in the equation of error. We even putting it in the calculations and all that. But why are we not doing it for other earlier classifications?
So I think for that I would say, yeah, maybe that cross entropy algorithm, cross entropy loss calculation may have some terms are related to that. See, I
Okay.
haven't gone through that reason.
Yeah,
So,
I also want, I'll put it in discourse also, because
yeah, at that time, yeah. Then I will also go through that
okay.
algorithm today only.
Thank you.
So, like Srinivasan, like, are you talking about these MLT calculations? Like, I have not seen like in MLTs, like they have included bias specifically.
They have no. So there's a separate bias vector, right? The weight and then bias.
Ah, that B, okay, that bias. Okay. So
So
that
he
bias
used the
was
word bias. I wasn't sure whether he's using this bias or he's using the intercept as bias.
That there is intercept actually.
Intercept.
Okay, that is intercept bias, right?
Yeah,
So
yeah.
because
Yes.
we overload the word term bias,
Yes,
then
yes,
Yeah.
even
Yeah.
then the same question, right? How come the intercepts exist in other calculations also? Why are we doing it only in software? Let me post a question in discourse, then we'll take it from there.
Yeah. And the intercept actually, the thing is, the intercept for other, I have to check that how this cross entropy works again to the full algorithm. But I would say in general, what happens in other algorithm, what was happening, no, like you are calculating loss. Okay, just think about that that intercept term won't change. Like for this model, see the -5 for model one, loss function is -5 plus x1. Okay, for second model, for second data set, or second model, you can say that your loss function will be -5 plus x2. Okay, so this -5 term is not changing. Are you able to get my point, what I'm saying? The thing is, the loss function is not that intercept term is not changing for any loss function.
Okay.
So that value, what will happen is, like for first model, if you are getting let's say 10 unit, and for second model you are getting loss as, say, let's say 16 unit. Okay, it is this value you got without that bias term or without that intercept term. And let's say I told you that intercept is somewhere around 5 unit. So first model loss comes around 15, 10 plus 5, and second model loss comes around 16 plus 5. It comes around 21. So it doesn't matter. It just increases both the units by 5. But our idea was to get which model is giving the lesser loss value. That would be same, no? In both cases, that would be correct. Same answer we will get.
Okay, I get it.
Yeah, and in other like whenever like we are introduced to those regression models, those things, right? There, if you see, like we are adding still the intercept through the dummy feature, right? That 1111. Okay, that is nothing but your you are adding that B component, right? And here, since it is an image like 784, you cannot make it 785, because in that case, like that image you cannot construct that image. That is the reason you cannot write directly W transpose X. You need to write W transpose X on other than B, because B is that one. Now one you cannot add to that 785 fifth feature, because it is a image data, and that is the reason sir was writing W transpose X plus B. Here you are not adding those dummy feature.
See, one more thing I would say. See, whenever you would see, like whenever you are just forgetting that bias term, just that bias or intercept term, you just think like you are ignoring it, that it won't change your answer. And when it won't change your answer, that is the case. And you just think like, yeah, you are supposed to add this one in every cases, but you are ignoring that because it won't. In that particular case, it is not changing your answer. You like that only. Like as I talked about, there no loss. Like loss is 15, loss is 20. In model one, loss is 15. In model two, loss is 20. So if you will add the 5 plus 5 term in both cases, your answer won't change. Still you will say that, yeah, your model one is giving the lesser loss value, like that. Or if you are confused, and I would say, yeah, you just think like every time you just add that interceptor, your answer won't change. For simplicity, you can think like that. So are you get what I wanted to say? Or
yeah, sure.
Or you just put yeah, if some other thing is there, you can put on the discourse. Or yeah, because I think in that case, yeah, people will be or I will also try what better way I can. Yeah, whatever I am saying that I'm feeling like, yeah, whatever I'm saying, you are not getting that point. That's why.
No, because the intercept, see, intercept and the bias that you are saying, right? Though the like terms are same, but they are not actually same. Because if you see that bias variance state of that bias is the
That is
expected value
different.
of the error, total error.
That is different. That is different.
Correct. And
Yeah.
intercept is like for each individual component you are adding a whenever you are doing the linear combination, that time you are adding a bias because it will give you a additional degree of freedom. See, if that component is not there, then what kind of like things we can learn? We can learn only like something which is passing through the origin, right? And since that is not always the case because your data may not be centered, okay, so that is the reason you are adding that additional B component to give a additional degree of freedom.
I think he is not satisfied with our answers. I would say, yeah. One thing, just in summary, whatever we discuss, we are talking right now. I would say just 2 point is that bias and this bias is that bias instead of both bias are different. First thing. Second thing is whenever just to think like every time you use that bias term, that intercept term, you won't get the different answer. And still, if you want to ask something different or something separate question, we are maybe your question we are not getting, then please post it on the discourse. Can you proceed now? Yeah. So
Yes, please.
yeah. So based on the following statements, it is essential. Yeah, this one we discuss as clinical by subject kinetic center. That's one absolutely. What will be the result of the following Python expression? Y predict equal to nearest neighbor and neighbors equal to 3 dot fit extend dot predict x test. Yeah, that error will happen. Yeah, because nearest neighbor object doesn't implement this predict. As we talked that, yeah, it's a lazy learner. So what could be the possible? One more question came in my mind. Yeah. So can you talk about some real life work where you will use this Canon Canon classifier? Just hello.
Any of these predictions, no? So actually, there is this joke about how the Rafael match people are predicting that he will lose. So even that they could use this prediction, right? They don't need to use the other methods.
One more means famous method which is there is like a movie recommendation engine. It works on this one only.
Okay.
Yeah. Like you ask, no, whenever you search some similar movie and you ask like you give some this one, you saw this some movies which is action drama thriller something like that, and then it will recommend some movie based on this only, like yeah, which is action drama
Okay,
thriller.
they have the
Like,
features. Okay,
yeah,
the genre, the actor, director, and then they use those
yeah,
features
yeah,
to.
yeah,
Okay, yeah.
yeah. So based on that, they just calculate the existence, and yeah, Canon works there very well. This recommendation system, whether it's a Flipkart product or movie recommendation. What could be the possible predicted value class obtained for the point x by performing Canon with Euclidean matrix and k equal to 1 on the following. So k equal to 1 what means what?
It'll be blue.
You just need to just calculate the distance, like this red one and this blue
Blue
one.
one will be shorter, no, because it's on the.
Yeah, yeah.
No. Sorry. I have to do the calculation. Sorry, can't do that.
Exactly.
Yeah,
So
I think red will be shorter. Yeah.
but yeah, I also need to check this one. Okay, so what will be the result of the following Python expression? A comma b equal to nearest neighbors and neighbors to. I think these questions you can do but just by using this, using that collab. Yeah, see, we get insights. Okay. Consider the following data set. Yeah, normalize the above data set using the meme square and predict the values corresponding to x1 equals 1700 and x2 equals 0.2 using K-NN regress with k equals 3 and employing the Euclidean metric. This one also again, just train your model and just put new, just add new data point. X1 equal to 1700 and x2 equal to 0.2. Based on that, you can calculate this one. I think yeah, we can move to the large scale.
Interestingly, the graded assignment is all on large scale data set, no?
Graded assignment. Yeah, the thing I would say.
Maybe I should ask this on Friday, but not today. But yeah.
No. But the thing is that earlier it was planned like I had to create that graded assignment for graded assignment, and I was working on this large scale part only. So I had some other work, so I created that. But later we got to know that some people who was allotted this to calculate questions on this part, this Canon part, he didn't create. He created question, but that was more like MLT type. So yeah, at the last moment, I did some questions for.
But that's interesting. Only thing is, so MLP, typically the practice assignments and graded assignments have had some link. This time there is no difference, but still fine. Hopefully this is data, this thing, so should be able to get that. But I like the way the graded assignment is going in terms of difficulty, right?
Yeah.
The initially it is easy and the last questions are quite difficult.
Actually, last question. Okay. Yeah.
It did work, right? So maybe others also, but see the problem with the MLP is that you will not get a wrong result. You will get some result. Whatever you do, you'll get some result. Right?
And I would say, one thing I would say, just at least in this time, just focus on that part. Like the 6 to 8 questions was there, no? One. There are actually the options are put intentionally to get the right. Whenever you will get the wrong answer, that will be also in the options this time.
Yeah.
So I would tell two things. Just first is don't train your model on that index part. Okay, the first column is the index. No, don't train your model on that part. Okay, because we are not supposed to train our model on index. Okay, so otherwise you will get wrong answer, and that is there.
Oh, okay. Because that is just an ID. That is just a randomly generated.
Exactly. That is an ID. No, you have to never. Not in this case. Any time you should not. You are not supposed to train your model on that ID. You should not consider that a feature. Yeah. So ideally, there are 2 features and 1 target vector.
Great. Thank you for that. Yeah.
And one more thing, what you can think of. Yeah, 2 crucial things is there. One, this one, and second, like how to use that standard scalar in that case. So these 2 things are there. And you would see in the first 5 questions, there are some data set, and the second question, one change is there. Like in both cases, you have to use the partial fit method, but one major change is that in the first question, we are converting that to ND array format, and in the second question we are just taking chunks, like we are keeping that in the data frame mode only, like a data frame type only. So why we are doing that, we put that question intentionally because in that case what will happen, like in the first case when you will convert, in any cases, not in this one, like whenever you will convert that in ND array, your model will be very fast. At least like you just check this one. Okay, I would say just try, just put the time value also in print time value before the implementation of model, and just print a time value after implementation of model in both cases, in pd.data frame and this and in that ND array format. Okay, just try that. You will get to know like how fast your model will when you work with just vectorization part, like after using that ND array part.
Oh, ND array is faster. Okay.
Yeah. Because for data frame model, what happens, like every time it has to refer the index part. Okay, like whatever you said, it has to refer that index part. Okay, so that's why.
Yeah, even the Softfax demo, the professor used, that code takes much longer. You really have to wait, right? Between 10, 100, each epo, right? You can actually count the time that it takes.
Yeah.
So that is on ND array. So if it is on data frame, it will be even less. Okay, thank you.
Yeah. So, yeah, activities questions were perfect. The assignment will not be graded. Yeah. Which of the following method can be used to handle large data files in machine learning? So there are 7 methods. Whatever comes in your mind. Like if you got some large data files, what method you will do? Like some other methods, whatever you come in your mind. Just think about that, I would say.
Yeah, this is tricky. I wasn't sure whether I didn't attempt this. I just read the question, but I thought both will be the right answer.
This one is right. That's not an issue.
Yeah.
Like otherwise, in general cases, you got some large data set. So what will you do?
Yeah, but like loading in batches and then do the training.
Yeah, that's correct. That is the first option saying, and second option saying some other.
Yeah, install into this Hadoop and Spark.
Yeah, these are there, and some other thing coming in your mind. So
one is, we talk about data set. We also talk about, in terms of rows, but even columns we can selectively read.
Even columns,
even the features can be read selectively, right? So that also can be done ahead of time, and you don't even read all the data, right? You read data only for some features.
Yeah, it's not like a common answer I have already. I'm just asking, just think of like if you got some bigger data set, like very big data set, and you have to just learn from that. So one thing you learned in this one in this lesson, like you use incremental learning. Okay,
Yeah.
so that will work now. That is that I even now.
And
But
use probably mode use all the processors. Like we use that in jobs equal to -1, right?
yeah.
No, that is one. Okay, that is just speeding up. But another is that can't we even read the data selectively, right? Not even read all the data.
Yeah.
See, suppose you have 2 million samples, right?
Yeah.
You may say that I don't need 2 million. I can just read every 10th one.
Yeah, that is also.
I don't know whether that is applied in theory, but it has to be done. Can't be just gut feel. Like it has to be done based on some knowledge of distribution and all the stuff. So
yeah, exactly. That is what I was also saying. Yeah,
But
one
is it
method.
possible like you can go to isn't the files are written in a sequential form? Whenever you are reading, without reading the first line, can you go to 10th line?
yeah, of course. That is not an issue at all.
See, you can
So
think
file systems. I used to work in operating systems, so the file systems are very smart. So you don't have to worry about that part.
No, because if you see that database lecture, right?
Yeah.
Yeah.
No, they haven't made it complicated. They've made it simple. But internally, there is far more, right? Each database has its own file system. Like Oracle, they have their own file system on the disk. So it is very efficient. So that has been, that's a known problem that has been solved many, many times.
Okay, so that means you can jump to anywhere.
Yeah. In a way, theoretically, right? It's like, in the CT, right? Remember, they used to say the dictionary assume that there is no extra time in searching in the dictionary, right? It's somewhat like that, right?
Mm-hmm.
So simpler way, yeah.
Yeah. So yeah, that is whatever Srinivasan said. That is also a good way, and I think is much better way. But also you can think as we talked in our statics, no, like all the data follow that we have large samples, large population, then it will follow normal distribution. So if we randomly select, like if let's say we have 1 crore data, 1 crore data points, and if our model is we are not able to train more than 1 lakh, so we'll select randomly 1 lakh piece. So I think more or less it will perform near to the closer to the accurate model. That using that null hypothesis and all. Whether I talk something alien or
yeah, sure. Yeah. Thank you.
Yeah, that can be also one way. But since we don't have to think about all those things, we have already the incremental loading part, and nowadays like
just to tell you one actual point, right? So I'm in the financial services industry, but there is one new fund that is launching in India, but it is actually what is called the US Total Market Index. So US, there are 4,000 stocks. There is an index created on them. Okay. And this fund has to track the index, which means they have to buy each stock. But what they do is beyond 500,000 stocks, they don't buy the rest of the 3,000.
Yeah.
So they select they select some 100 out of the 3000, which will represent everything. And then that is what they do. And they faithfully see, the index is a Excel sheet work, right? I can create the index and I can track. But by doing this, they select only 100, 200 stocks out of the 3000, still faithfully track the index. So, and that is a huge algorithm. I mean, there's a lot of work done on it, but they actually do it. And these are financial people, right? They have to be answerable. Right? You can't, I mean, it's not like our coding, right? They have to be answerable to do it, and money depends on it. They actually do that. So that is how I know that the sampling works.
Yes. That is what we are studying in the null hypothesis and all. Like, just take some, take some samples. If it is, if lie in that 0.05 p value, then it will work. Okay, so second question, second one comes SQL process, and that's how we represent. I was also talking about. Okay, let me come to this point only. Yeah, actually, I was talking about this Nifty 50. That is also representing our market, no? Like, it is just a collection of the biggest.
No, but there is a defined parameter. There is just the largest market cap company.
Yeah.
So there is no further selection.
Okay, so that you are correct. This is based on the market cap only. Not,
but even India, I can give the same example. See, 50 stocks you can manage to buy. Suppose I say there is India also, there are 2000 plus listed companies.
Yeah.
Suppose I create an index based on all the 2000 companies. The index can be created using Excel, not an issue. But if you have to buy those stocks, right? The 2000 company, it may not even be available in the market for trading.
Yeah.
Right? See, suppose I ask you to buy every rice product made in India. Some of the rice products may not even get it, right? They may not be available. They may exist on paper, but they may not be available. So that is when you have to do the sampling. And they actually, India, it is not allowed, but the US, they have done it for quite some time. They have successfully done it.
Okay. Yeah. So I was thought I coming in my mind was like, we can select some stocks, some top stocks from the real estate market, some from banking states, like some from something like that. Yeah, but you said whatever, that is correct. Yeah, so in the second question, we are reading about the SQL processes large data in batches and updates the model parameters for each batch. The percent the aim of incremental learning for the learning model to adapt the new without forgetting.
No, I think the percentage is extra. So that is.
Yeah, that is what I'm thinking. Yeah, incremental learning is a dynamic technique which is applied when training data becomes available gradually over time, or its size is out of system memory limits. Yeah, both these statements. I think actually we would have just removed this term, but the configuration team, for that only, like in overlay we use that percent term, but I think they used they typed this one also, configuration team.
Both are correct, right?
Yeah, both are correct.
Just to be the thing, so statement 1 is the situation where you have a large data already, but you don't want to read all of it. Statement 2 is in a situation where you don't have all the data now, the data keeps coming.
Exactly. So can you tell about this this one? Like one case will be like you have large data set, and in one case like the data is continuously coming. For that, can you give one example?
Anything with COVID, no? So that is a clear example, right? Because we keep getting new variants. So
that's a better example. Yeah, right. The following estimator implement partial fit method in regression. Which one?
SGD, right?
SGD, exactly. The following estimator doesn't implement partial fit method in classification. So which estimator doesn't implement partial fit? SGD classifier, it uses that. We can use partial fit. Perceptron also.
Logistic doesn't, right?
Yeah. So in the fifth question, we can mark. Doesn't,
but
hello.
Specifically talk about Gaussian, but Gaussian also will have partial fit, right? Or doesn't have partial fit?
In the Gaussian, I think we have, no? In the case of Gaussian, I'm not sure. I need to check that. In the Gaussian, I need to check that.
No, he in the lecture notes he talked about multinomial NB and Bernoulli NB and SGD and all that and Perceptron. But I was wondering why is Gaussian not there? I thought I couldn't find any reason why Gaussian can't do partial fit.
I also need to check that whether I'm not sure whether we can apply the partial fit on Gaussian or not. It is just in the lecture what happened, like they would have given some examples in that fit. Okay, like that. Whatever the example came in is yeah, whoever created that collab, whatever example came in his her mind, he just wrote those things. That, but yeah, have you searched about that Gaussian whether it's this partial fit or not?
No, I read the lecture only last night. That was my homework to go and check whether it supports
Okay.
partial fit. I'll do that.
Okay. Yeah, the thing is like we all see the case is like sometimes you would be thinking like, yeah, people are just many people are thinking about, yeah, whether this is there or not. But the thing is like there are so many libraries, and other libraries work on some different methods and all. So we just we also don't remember each and everything. So there are much nowadays like much better algorithms are there, much better libraries are there like Keras, and then you will when you will move to this deep learning, then all these things will be like just as you think, no, like some stories you read about in your second and third standard, something like that. Because nowadays
Gaussian NB partial fit. Gaussian NB also has partial fit. I just
yeah. Yes, stochastic gradient descent can deal with large data sets effectively. Yeah, that's correct. We can break the large data set into smaller chunks and process them sequentially using ZDS, which means we need to only one chunk into memory at a time. That's correct. And actually correct explanation also. Yeah, Gaussian. Yeah, count vectorization converts a collection of text documents to a matrix of token counts. So that's correct. And one thing, uh, what are the different methods have you learned till now to convert this text documents into a matrix?
only count and hash has been decided, right?
Okay.
Only count and hash has been discussed so far.
Okay. Yeah, there are others. In this case, partial fit, yeah, obviously we need that hashing vectorizer, but there are some other methods like TF IDF that we also use many times. So just read about this one, TF IDF. I'm not sure whether
it is there in the previous graded question. We just did it. I want to check that is TF-ID is another format, right? Yeah.
But it won't work here. But yeah, that is also one case. Yeah, make the correct statement about count vectorization and hashing vectorization. So count vectorizer does not store the resulting vocabulary, but hashing vectorizer stores it. Actually, it's just opposite. Hashing vectorizer doesn't store the resulting vocabulary, but count vectorizer stores it. In count vectorizer, each token transforms to a column position instead of adding to the vector, but hashing vectorizer does the opposite.
This was the opposite, right? Yeah.
Hashing vectorizer is a good choice if you are falling short of memory, and it's also, however, a count is a good choice if we need to access the actual tokens. That's correct. Yeah. We do not force a matrix size explicitly with count vectorizers. The matrix size is based on how many tokens were found in the vocabulary. That's correct.
Yeah, correct.
Yeah. Which of the codes to import count vectorizer and hashing vectorizer? Yeah, learn dot
feature extraction. No, it has
yeah. Feature
text.
Yeah. Text. Yeah. So what is the difference in third and fourth? Let me check.
I think there is an underscore. I think the fourth is correct.
Okay. Yeah.
Yeah, these are the, by the way, these are the age questions. So some of them for me also this I may not be able to figure out if there is an underscore or not.
Yeah. So yeah, what is the shape of X mat that we will get? We'll apply this. So have we given the data set? There would be some data values. I think they missed that. This text document, no? Is not given, no? Yeah. They just missed that. There was a data set. So based on
should
that
be
data
19.4, right? Or 19.
Yeah, 9 to
19.1, right?
Yeah. The thing was the data set is given or not. I'm not able to.
But it's a guess, right? Because 19 may be the number of words, and then we need to find out.
Yes. But the thing are there can be many sentences. No, in that case we can that it will increase. But yeah, that is 19.1. That's correct. But yeah, they missed that because there were as a sentence like one para was there like this is the text document, and yeah, based on that just answered 9, 10, and 11. Yeah, they missed that. Okay, yeah, then we can answer based on that only. So here we are just mentioning that yeah, number of features are 10. So yeah, in that case, yeah, it will be safe, will be around 10 common. No? Yeah, we just it's a random yeah. We need to we need data set actually, yeah, that text documents, but here's yeah, it is missing here. In async vectorizer build analyzer method is used to what one, like yeah, return a callable to process input data. This one, yeah, so I think yeah, we are at the end of this part. So yeah, we need to discuss this practice assignment. Okay. Okay, I think I would have that collab. Okay, we can discuss it with the collab. Okay, are you able to see this collab? Okay, I'm just sharing this collab.
No, not yet. We just see the. We can now. We can see the collab. Yeah.
Yeah. So yeah, for this one, yeah, this one is the text data. Yeah. So this is the text data. It is talking about some meta. Yeah, about metaverse only. So yeah, we just vectorize this one. Like can vectorize the given text data using count vectorizer object. So what is the shape of the? So yeah, one question. Just one more question. What is count? Like how count vectorizer and hashing vectorizer works? Hash vectorizer. And why vectorize? See, one term, one question. Like why? What is the meaning of vectorization? Like here.
Okay, this is actually, there is also dict vectorization, but the way I understood was that, because you can't, this is unstructured data. So vector is a structured data. So because our algorithms can work only on structured data. So we're just taking the unstructured data into structured data by following some algorithm, some method, so that we can get back to the unstructured data also in some form.
Yeah. Correct. Yeah, so we are converting the words into the numbers to refer that word. Yeah, like that. Whatever you did, that is correct. Yeah, that is the use of vectorizer. And what is the difference between count vectorizer and hashing vectorizer? Like, yeah, how count vectorizer works and how hashing vectorizer works.
See, count is going to take each instance of the word, any word, and then get the number of occurrences of it, right? So it takes each word. So that way, the number of samples will be the number of rows will be the number of words that are there. Hashing basically looks at then basically that's why it creates a dictionary, right? Because every word will be there in the final output. Hash, what it does is it puts a hash table and accordingly creates that thing. But I want to go look at the output of hash and see the difference. But this is how I understood. But I think I'm a bit confused on this.
Yeah. So there are many hashing algorithms. Yeah, just one you can think about an algorithm which will just place all the it thinks like that. It gives some common some common token to word. You can think that it is allowing some token to this word metaverse. So in this count vectorizer, you just whatever you said, that's correct. Like it will give this one as 1, this one as 2, something like that. That's how it works. Like see, just this one is, it will talk about this one is the first sentence. So 1 comma and whatever is the word that whatever is the position of that word. Okay, like that it maps this one. But in the hashing vectorizer, how it works is like using that there are different hashing techniques. Just one technique you can think about. See, when you have to search any word in that dictionary, suppose you have a dictionary. Okay, you have to search a word. Just think about this. Yeah, this word just metaverse only. Okay, how you will search? Hello. I'll try to explain. Yeah.
How will you search? Yeah, in the count, you have to go just look up that it's a dictionary, right? So you just have to assume that, you can get the key number of occurrences because you're just a dictionary method.
Yeah, no, not about this. Just think about you have your old dictionary with you, like that one. That
You have to go look at M and then E and go down that way. That is vector. Oh, that's saying is hashing because first you look at the first letter and then the second letter, 2 letters, and then you get to the page.
It doesn't work like that. But I'm just asking that, like how you do that. You did like that only, no? But the
Yes.
thing is, so the job of this hashing vectorizer is to minimize that searching time. Okay. So suppose in hashing vectorizer, let me just. I won't explain in that details. You can search, read about this because there are many algorithms, and just I will just talk about some in brief details. Yeah, whatever since we have time. So yeah, I'll talk about this. Okay. So just think about this. Yeah, you have some word like what it does is like it creates a just it's a term is like it's a dictionary on it approach. So in that it just creates a dictionary. Okay. So oh, it is not taking. Okay, okay. So I think I need that scribble pad. I don't have it right now. I want to find this. Okay. Okay, server needs to okay, just let me or I'll let it be. I'll just talk. That's okay. I'll talk orally only. Okay, the thing is like in the what it does now in hashing technique, what it does just think about this manual method. Okay, so what will just one example. There are many algorithms as I told you for hashing to do this hashing work. So in one method you can think about that. You just think like if you have word metaverse, no, you just what you do is like you calculate the how many number of words are how many number of yeah letters are there like 3 to 5 7 9 letters are there. Okay, so you created a dictionary where you just write the key and value. Okay, in the key part you just plotted this metaverse like at a value of 7. Okay, 3 is yeah 7. At that 7 you put the key and or at that time you just put this value metaverse. Okay, so like that you just plotted all these words based on the count of that word, based on the count of the letters. Okay, so in that case one new term will come like what you will do like if you have two words with the same number of length of words, it can come, no? Hello, hello.
Yeah, we can.
Yeah,
Yeah.
yeah, for that also there are some other terms like there are collision techniques, that is also two types. So it is already a big topic, this part. So yeah, just read, you can if you want you can read the, or for common sake yeah you are like yeah if you want to just learn about in one sentence for here, you just think about yeah hatching is a technique to map the data like to provide a special token to each word, so in such a manner that it will take lesser time to search that word, something like that you can think here. And you can search about this, there are these collision methods and how these things go. So yeah, let's come to this question. Yeah, vectorize the given text data using count vectorizer object. What is the six of text data after vectorization? So yeah, we just imported this count vectorizer, and yeah, we just use this dot fit transform method to let me connect this one. And one more thing I wanted to say, like yeah, just 2-3 days back only, I also got to know this one. There is one more library called PyForest. Do you know about that one?
Which library?
PyForest, like yeah.
No, is it something to do with the random forest or something?
No. It is just yeah. Just few days ago, I was reading a post on LinkedIn. There, one guy has posted this one, and I haven't also yeah. Like yeah, 1-2 days back only I was trying that. Install PyForest. Okay, so the good thing about this one is because after installing this one, you don't need to import each and every thing every time. Okay, whatever the all the comments that guy was has written there. So yeah, whatever the common libraries are there, no, that is already included. It is just union of all those libraries. Like after using this one, you don't write to every time you have to write like numpy.np something. Like you have to import import numpy as np. Hello.
Yes, I got it. This is going to be so this is going to be heaven sent, because even for the vectorizations also, right? I have to remember sklearn.model selection.text.
Yeah, I also need to check that, because that guy has promised, and I just check for the numpys and the pandas, so it worked. And just to cross check this one, okay? Because I also just got to know like 2-3 days back on, and I tried for the just see. Till now I haven't imported in library, no? Okay. Yeah, just let me try with this np dot range 1,10. Just let me see.
Right?
Yeah.
A range, no? Oh, NP is not defined. Okay.
NP is not defined. Yeah, the error is coming. Then
you have to use numpy, right? You can't use NP.
No. It has saved in NP only. Like, but I haven't imported that. No, I just installed that, but I haven't imported pipe forest. I think after importing this one, it will work. But NumPy doesn't have this.
A range, right? You have to put A range, not range.
Yeah. Okay. Otherwise, I can just convert in this error also. Yeah, it is working now. This one NP. After using
and
this,
you didn't even use NumPy, right? You used NP.
Yeah. It has saved in such a way, in such manner only. Like for NumPy, it is saved as an NP. Pandas, it has saved it as
PD. Okay,
yeah,
great.
like that.
So this is going to be very useful for the OP.
Yeah. I also need to check this thing, but just verify this one. Okay, I also just few days back only like got to know about this one. I tried this in NumPy and Pandas. For this one, it worked, but I'm not sure. Okay, just try just this one also. Okay, just yeah, it is working. It will be very helpful, no? Hello? Yeah, it is working for this one.
I'm also trying to do my demo. Yeah, because I had quite a few of this, the same MLP demo. Yeah, it is working.
This count vectorization is also saved in this one. Yeah, that will be very helpful for OP. Yeah, that's correct. And yeah, for us also, like many times it's just like you just wrote the code and it is giving error. This is not defined, that is not defined, and again you have to type this one. And many times, as you said, no, that this is whether it is under count vector, this is underscore or not, like that. Yeah, so 9,99. Yeah, this one is correct. And this one question is correct. And the second question, let's go to the second question. What is the shape of text data after vectorization after the term that appeared in less than 2 documents are ignored? Okay. Yes, so here's written the code like new count vector after the first 2 term is ignored, then it comes around 9,20. So third question comes like what is the tokens associated with word metaverse? Yeah, here they have directly just put it's better. First let's see. Just plot all the dot vocab. By using this dot vocabulary, all the terms. Here we can see that there are actually two words. Metaverse is got the token number as 51, and metaverse has got the token number as 52. For metaverse, we can directly put this code. We got this 51. Okay. So in the fourth question, what we have done is like this is the docs, this is the text document. Write a code to convert the above text into an array after tokenized it using count vectorizer with 10 features. So what we did is like we just tokenized it and then we converted it into array format. Okay. So here we have written a function like array maker. What is doing is it simply first it is converting it to the count vectorizer. Yeah, and after that x dot to arrays. So yeah, it's simply converting this. So define a function key called k closest to in the Python with the following signatures. Like define k closest. X is the set of vectors as np.nd array, and p is the test vector, and k is the integer. Default value is 1. Okay. So you know about this. You have read about this in a SciPy library.
No,
Hello?
we have not. And this yesterday also we saw that not even nearest neighbors, right? Even he was using that arg partition and all the stuff in the MLT lectures. I want to read that up. That is another part of NPy that I didn't know.
Yeah. Let's read about this one. This one is yeah. So what is the question is saying? Yeah, closes this well. So it is more like a you're this kind of question. What do you say? MLT type of question. So yeah, it fits the nearest neighbors, and then yeah, it calculates this x closest dot near. So I think the same guy has created the questions on this one. Yes, so I just mentioned also like this question is stable for MLT. Yeah. For this question, yeah.
That nearest neighbors, right? It is going to look at each and every data point, right? So it is going to be quite slow.
Yeah. So that's why you just mentioned this one, like these 4 columns, and yeah, these 4 rows. Then it is calculating this p, whatever the values are close to this one. So yeah, different the function called distance in Python with the following signature. Yeah, it is asking to write a function for to calculate mean cost distance. I think yeah. First one is the core data in this one, and there is in SciPy there is a library like directly mean cascading that you can use also, or you can write this function. But it is like more like a this MLT type questions. Yes, yeah. So yeah, common data set for this one, like load the data set and split it using yeah this dot load digits. So yeah, there is in the data there is one data set like that digit also that is in the scalar library. This library, this one is also one also contains that all the digits like from 0 to 9, and yeah, there are 1797. And this one, all the data are presented in 8 by 8 feature. Yeah, 8 by 8 features, and yeah, the shape of this x dot shape. Yeah, there are 1797 data points. So let's learn this one. Data set is not defined. Yeah, data set. Import data set from data sets, data sets. I think I also need to check that. I think I also need to check this one. I only have created this one, but I don't know why I removed this one. Okay, I just need to check this one. Okay. I also need to do a Google search. Like, okay, let me see. Because we can't move further. Anyone remember like how is the zip code? So what's the problem? Yeah, like how we import this one data sets? Like, what is the correct syntax for to import this one?
So can you just delete data once?
Data, which one?
You're downloading this MNIS data, right?
No, this is normal load digits.
Achha.
Okay. So import dataset from sklearn.datasets. Link.
Okay, yeah. Something like that only.
Yeah. You can just do a sklearn dot and then press control space or tab. It will display all the parameters. Yeah.
Yeah, sklearn.datasets import
Yeah.
load digits.
Sklearn dataset. Yeah, I was just confused something with that.
Datasets import.
Yeah, sklearn datasets, that will work. No. What you just said? Just
Yeah,
say.
from sklearn,
Yeah.
the first the first import, remove that, right? From sklearn.dataset
Sklearn.
datasets.
It will work.
Dot. Okay.
It will work actually, because we have used the dataset dot load is.
Yeah.
It will
Yes.
work.
Correct.
Yeah. I don't know why just I removed this one, or some other people has removed, because yeah, maybe to check this one, that path first. Okay, it's okay. It is not working. Yeah. So yeah, we imported this one. Yeah, digit equals, yeah, the shape is around 1797, 64. Yeah. So how many levels are there in the data set? To check that, yeah, just we can check the unique counts of np.unique of y vector. Yeah, it comes around, yeah, this one. These are the unique. And what will this do? This count, what will count that? This one, this count, what will be the saved in this count? Yeah, count variable. Any idea? Or you have used this one, this np.unique, no?
So count will be the number of unique items. Yes.
Yeah. Like how many times this 0 is repeated in the y vector? How many times this one is repeated in this one?
Frequency, kind of.
Yeah. Frequency, exact word. How many times level 7 is there in the data set? Yeah, second question is related to that only. We simply stack this one like unique and counts. Yeah. Now we are able to see, like, yeah, how many times which word, which word it is repeated, like which digit is repeated. So we are able to see, like, yeah, 7 is repeated 179 times. Yeah. So yeah, the correct answer will be 179. Okay. For that is, what is the accuracy score you got? It comes around point. Yeah, we will just see what is the best one score. Yeah, we just train our model. Okay, I think I should try with by removing this part. Okay, you guys can try this pipe forest. Okay, just try. And maybe if it would be better if one of you, like, just write a Discord forum, and where you can mention all the parts, all the libraries which is not working after importing this pipe forest. Okay, so we will get a good set where this pipe forest doesn't work. I think you got what I asked. Hello.
Yeah, we understand.
Yeah. So yeah, the second case is, yeah, we created a pipeline where we just we use this standard scaler to scale the data set, and yeah, we apply this logistic regression where we put that multi-classes multinomial solver equals SAG. So what is this SAG represents? Can anyone tell the full form SAG? Yeah, hello. Anyone?
No clue actually.
Stochastic average gradient. Stochastic average gradient. SAG is there.
Yes.
Yeah. Actually, just for visualization, I just created. Yeah, just print this one. Like you were saying, like there are one more metric, one more for this administrative data set. Yeah, where we have 514 yeah, features and 514 by 514. In that case, see here how this word one is represented here. Okay, one is here. In what color it is saved. So if we would have the more number of features, no, like yeah, this pixel value, yeah, it is plotted on 8 by 8. If we have that, if that would be more, then we would see that we will see the more clear picture of this one. Okay, just check for some other values. Just let's say at 380 place, which let's see how the performance of our model that is working correctly or not. Okay, index 300 is okay. Yeah, 360 value is there only. Yeah, so we are able to see that at the 30th place the word is 3, but it is representing, I think it is predicting wrong. It is predicting something like 0. Is it 0 or it is 0? No, yeah, it is predicting as 0. Yeah, here our model is working wrong. For 200, let's just check for some other values. Yeah, this time this is 2. Actually, I am also able to predict this one, like whether it is 2 or not. Okay, print actual value from test data is 1. Yeah, here we so for that this function, yeah, it's okay. That depends on our model, and so we are not able to interpret this. It was better to that this one only. For 200 it is predicting, yeah, we are able to visualize that, yeah, it is 1. Yeah, it looks like something closer to 1. The thing is, it depends on the pixel size. Okay, if the more will be the pixel size, then we will be able to see that one more in more clear way. Okay, yeah, let's create this, just print this classification report. Yeah, from here, like, yeah, we can answer all the rest of all the questions whichever is there. Like, yeah, here it is written already, but yeah, it is like, yeah, some different codes for this one. Accuracy score, yeah, we have to import this one also. So remove die, yeah, I had written that, like, I imported all these things, but it is not written here. Yeah, we have to import these things also. Otherwise, yeah, from here on, like, we can answer all these things. Yeah, F1 is score, and yeah, accuracy score. Using this classification, yeah, classification report, we can say this. Yeah, so yeah, that's all. Or otherwise, just to get that particular value, yeah, we can import this one, recall score and F1 score. Based on that, you can work. So I think, yeah, we covered all the programming questions and activity questions. So in the next session, what you want, like in solid structure session, so whether we will ask some questions, yeah, just small questions, or big size, just like as I talked about the recommendation engine, something like that. I'll create a model and I'll just try to explain that model, or whatever you want, you guys can say. Hello, what you guys want? If you guys are interested, then I can show some that, yeah, some data set, and yeah, we can work on some, as I talked about this movie recommendation engine and something like that. Like, we will see some data set, movie data set, and yeah, based on that we can work on that. Or yeah, otherwise also we can do that. Yeah, some simple questions on, yeah, some questions on, yeah, this one, Canon classifier, Canon regressor, and yeah, some questions on large scale data set. And yeah, that's something like, we will create some questions in such a manner that it will help you to in your graded assignment.
Yes, so that would be great.
Okay, okay. So yeah, we will do that. Okay. So I think yeah, more or less we are okay with this session. Yeah, we have covered this activity and practice questions. In next session, we will discuss that part. So
Okay,
yeah,
sir.
yeah. So that's all from my side today. Yeah. So anyone wants to anything else to be discussed?
Sir, when are the results going to be declared, like for the quiz one? Any idea?
For quiz one, I like few days back, someone was showing the graphs, and yeah, the results are good actually. So maybe next time they can try to create some tough questions. But yeah, this time result is good, and
Oh,
I think yeah, but yeah, it is like yeah, all the things we have got, but I'm not sure when the yeah configuration team will.
okay.
Yeah,
Actually, it's been this is the longest since they have declared the result, because they generally declare it in a week's time, and it's now kind of 1.5 weeks. So that's okay.
the results are ready. I think yeah, because few days back only I just saw I saw that those graphs and all.
Okay, sir. Okay.
Yeah, but I'm not sure why they haven't declared the result. Okay, just yeah, put this question on the discussion. Yeah, someone has put this question. I think yeah, just today only I was seeing. Yeah, I'll ask and I will confirm and I'll just inform there. Yeah, I will write there.
Got it, sir. So,
Yeah,
actually, sir, just one more suggestion. If it's possible to have a session in which we are like possibly at the very end of sort, but like basically what I want to say is that you have these contextual problems, such as you just mentioned the movies, where
yeah,
KNN would work wonders, right? Like,
yeah. Recommendation is yeah,
so, like this algorithm is kind of very good for this data set. So if we could have an idea of all the algorithms which is very good for a particular data set, that would be great. Like, just
yeah. I got your point. I got your point.
yeah, yes. At the very end, if possible, or something of that would be great.
Will ask them to do, but the thing is I would yeah, obviously we will just try to we will do this one. Okay, but also I would suggest here personally, see, the thing is like the course is our from it's personal, my personal view, like the course is like in the 12th week, like in the every week we have 2.5 hour session. Not so many things are still to explore, and the thing is sir is also trying to cover so many things.
Yes, sir. I
So
understand.
yeah, yeah,
Okay, sir. Okay, okay, got
yeah.
it.
So
Possibly,
you can,
possibly after everything, we can have that. Like,
yes, yes, yes.
okay,
Yes,
sir.
yes, sir. And just try to explore the things. Like it is just think like sir is giving you the brief idea about the all the terms, and yeah, you can just expand your knowledge on each topics
Got it.
from
Got
your
it.
side. Just refer some Kaggle data sets and just try those things. You just see the data set, like how you will clean the data sets. The major problem would be like you will see when you will see this movie data set. No, there you will see that yeah, you have to extract all the like whether each movie is there. You will have some JSON files you have to import from there, and you have to create some features like yeah, which is like the genre of the movies and all these things. Okay, like that you have to work on the data, but yeah, just try to see those things also.
Okay,
We
sir.
can do that, yeah, but yeah, we can just say that yeah, this will work, but because in the syllabus I'm also seeing yeah, there are a lot of things still needed to be covered. And one more thing is that yeah, SQL learning is not just end of the world. After that you will just learn about keras and all, deep learning will come.
Yes, sir. TensorFlow.
Yeah,
All that.
yeah.
Got
All
it.
these things will come. So, yeah,
Okay,
so
sir.
that's all. Yeah, that's all about me from my side. Yeah, so yeah, we will meet on Friday 11 a.m. Yeah,
Yes, sir. Thank you, sir.
yeah, bye all. Yeah, thank you. Vignesh, are you there? Yeah, yeah.